So nonlinear systems equations sounds pretty impressive. You can impress your friends solving nonlinear system equations. It's pretty cool. But basically what it means is that we're no longer looking for the intersection of two lines, but because it's a system of equations, we are looking for an intersection. It's just that these particular equations don't have to be just lines. In fact, we've got a parabola for one and a line for another one. So can anyone venture a guess as to what the actual solution to this nonlinear system of equations is?
Negative 5, 8, and 2, 2.
Negative 4 and 8,
Negative 4.
and 2 and 2. Nice. So it's just where the lines cross each other. Now, if I wanted to prove that I got this right to myself, what do you think I could do?
Plug it in.
Yeah, plug it into each of these and find out. So, great, I can do that. It should satisfy both of these. We can certainly check the bottom one pretty easy. Negative 4 plus 8 is 4, so it checks there. And it checks in the first one, so that's your solution. But you're not always going to be given a graph, so what could you do? Well, let's see. This is example B.
Also, your section, sometimes you have two different ones on your YouTube channel. One is from fall of 2024, and then the other one is from 8 years ago.
Okay, so I like to keep mine fresh. Looks like I got one from the fall, so that's pretty fresh. You've got a lot of options as to how you want to solve this. So a lot of the tricks that we've done in this chapter so far, like the addition method, substitution method, even Cramer's rule and inverse matrices can be made to work here. You just have to be careful of what the variables are that you're working with. What do you see in terms of working with this one? How would you solve this one if you had to solve?
Say substitution.
I like substitution. We can easily solve for y. If I move that to the other side, I'll move the 7 to this side. When that happens, when you change sides, you change signs. Thank you. So we'll end up with x squared minus 7 equals y. And I can plug that expression into my other equation. So great. Let's substitute that into there. That'll give me 2x squared plus 3 times x squared minus 7 equals 24. And let me just write that here, x squared minus 7. Let's distribute. We'll get 2x squared plus 3x squared minus 21 equals 24. Combining like terms, 5x squared minus 21 equals 24. 5x squared equals 45. What would you do to solve at this point? It looks like a good way to solve. Yeah, definitely divide both sides by 5. So we end up with x squared equals 9. What does x equal? Oh, nice. Fight for safety, guys. It's plus or minus 3. And let's be careful with that plus or minus, because a lot of times in these types of problems you're going to end up with two solutions. And in particular, looking at this one, well, let's just clear, I'm not sure what this is all about. Let's make that a little bit darker. You can see that there's two solutions. So the first one is x equal 3. The second one is x equal negative 3. So let's put in that plus or minus, that all-important plus or minus. And then we can go back and solve for y. So when we set x equal 3, we end up with 3 squared minus 7 equals y. So that's going to be 2 for y. If we set x equal negative 3, same thing's going to happen. You're going to get negative 3 squared minus 7 equals y. 9 minus 7 is going to be 2. So if you set in x equal 3 or negative 3, you still end up with the same thing. Keep in mind that myself and WebAssign are going to prefer answers that are in coordinate pairs. So your final solution should look like 3 for x, 2 for y, and negative 3 for x, 2 for y. Although WebAssign has this annoying habit of asking you to write it in particular orders, like the smallest x value first and then the smallest y value next, that kind of stuff. Yeah, I really don't like it. It's probably my biggest complaint about WebAssign, but I'm sorry, there's not much I can do. All right, so let's look at the graph. Let's see that this corresponds to our solution. The cool thing about Desmos is that you can just click on these points and see them. We'll spend a little time later with your graphing calculator. Make sure that you can find those points as needed with your graphing calculator as well. So let's move on. Let's move on to example C here. You can see it there. I'm going to leave it up as I copy it myself. So example C. You've got 3x squared plus 4y equals 20. That's 23. And then 2x squared plus 5y is equal to 6. So, all right. Now, this is something that you actually could do on your graphing calculator if you wanted to. But unfortunately, when you do that and you try and find your solutions by clicking, even here on Desmos, you get these ugly looking decimal answers. And I'm going to be looking for exact solutions. So what could I do here? Well, let's see. We did one by the substitution method. Let's do another one by the addition method, just for some variety here. Do you want to get rid of the x's, the x squareds I should say, or the y's? Which one do you want to get rid of? X's? All right. So that's going to mean we're going to multiply each of these by something.
-2.
Nice. Well done, Antonio. Multiply the top one by -2, the bottom one by 3. That way we'll get coefficients of -6 and 6 respectively. And that'll help us cancel out the x squared terms. So that's going to be -6x squared minus 8y equals -46, added to 6x squared plus 15y equals 18. Okay.
It should be 12. Because it's, oh, never mind, my brain.
Okay, you had my attention.
My brain.
No worries, no worries. So what do I end up with? I end up with 7y equals -28. So y equals -4. Great. I was hoping for a nice even number. We got one. But keep in mind, your solutions are of the form of x and y. They're coordinate pairs. How do I find the y variable?
Oh, right. You mean the x variable?
The x variable, sorry, my bad.
Plus the -4 back into one of the y's.
All right, let's plug it into the bottom equation just because it looks handy and easiest. So I'll plug that in here. End up with 2x squared plus 5 times -4 equals 6. That's a -20. So I'll add 20 to both sides and get 2x squared equals 26. Okay, not so bad. What do I do to solve? Divide by 2. X squared equals 13. Uh-oh, I see trouble in paradise. Elizabeth, what do I do? What could I do to solve for x?
Use the plus or minus.
Oh, yeah, well done. Plus or minus square root of 13. So keep in mind, we got this when y was -4. So there's two possibilities. Either there's a square root of 13 and -4, or negative the square root of 13 and -4. Those are your two solutions. If you actually looked at this on a graphing calculator or on Desmos, here's what you would see. You'd see these 2 points, and you look at that and you're like, is that the right answer? But you can calculate square root of 13 and you'll find out that, oh yeah, it does intersect right about there. So, looking good. 2 solutions. Let's keep rolling. Example D here.
Oh, boy.
How many solutions do you expect on this one?
4.
4. So we're going to have to be careful on this one to get all 4 solutions. So again, let's copy this down. I'll leave that up there while I copy this down. Example D. Got x minus y squared plus 4 equals 0. And 2x squared plus y squared minus 5 equals 0. So a parabola and an ellipse. So this is a free-for-all. We've done one by addition, we've done one by substitution. What looks easiest to you?
Addition.
Addition looking good?
Take
All right.
Y first.
Yeah, so we'll get rid of the y squared. The important question here, Nora, is what do I get when I add these two equations together? These aren't like terms. I can't add these, right? I can't get 3x squared or 2x cubed. It's just 2x squared plus x plus 0. Then what? Minus 1. Yay. Well, now I've got a quadratic equation. So if you're looking at that going, oh, it's just terrible at factoring these things, I have sympathy for you because I was terrible at factoring these kinds of things myself. So let's just take kind of a quick peek at a little trick here. What if we graph y equals 2x squared minus x, 2 minus x, no, plus x minus 1. And then you can easily find, even if you have a graphing calculator, you can find these points of intersection. This goes through at 1/2 and -1. So your two solutions here are x equal 1/2, x equal -1. So we got those. If you wanted to, you could end up factoring those things. So it'd be x plus 1 times 2x minus 1. That's how it would factor. But we already have the solution, so that's really what we need. X equal -1 and x equal 1/2. We still need to figure out what the y variable is. So let's do that over here. I'm going to set x equal to -1 and solve for y. Which equation do you want to use? The first one or the second one? First one. I was hoping you'd say the first one. Thank you. -1 plus, or excuse me, minus y squared plus 4 equals 0. So it's going to be minus y squared plus 3 equals 0. Let's move the y to the other side. So it's going to be 3 equals y squared. What does y equal? Ah, well done. Somebody's getting really good with that plus or minus. Thank you so much. It's plus or minus the square root of 3 equals y. Now let's just pause for a moment and write down our solution in terms of x and y coordinates for this part of it. There's two parts, right? When x was -1, we got either y was the square root of 3 or y was negative the square root of 3. So that's two of these. Let's see about when x is 1/2. So set x equal 1/2. So again, we're going to use the first equation, put in a 1/2 minus y squared plus 4 equals 0. 1/2 plus 4 is 4.5, which I'll rewrite as an improper fraction. What's 4 and 1/2 as an improper fraction? 9/2. Like the last one, I'm going to move the y to the other side and get 9/2 equals y squared. That gets rid of that negative. Makes my life a little bit easier. You can take the square root on both sides. You can leave it as the square root of 9 over 2 if you'd like, even though the numerator part simplifies. I'm not really interested in making you rationalize the denominator, that's a different problem. I don't care about that so much. So my final answer there would be when x is 1/2, y could be square root of 9/2, or x is 1/2, y could be negative square root of 9/2. So 1, 2, 3, 4 different points for that particular problem. Yes, sir.
Two questions. Firstly, where did you get the 9/2 from?
1 plus 4. That's 4.5. So 4 and 1/2. If you multiply 4 times 2 and then add 1,
Okay.
that's 9/2. So where's your second question?
And then what happens to the negative with that portion? Because it was a negative y squared plus 9.
When I move the y squared to the right-hand side, that negative disappeared. That's actually why I moved the y squared to the right-hand side, so that I didn't have to deal with a negative in this problem at all. Good questions. Appreciate them. Thank you. Anything else on example D here? Let's see. Let's take kind of a quick look at example E. Now, this one looks a little bit interesting. How many solutions do you think there are to this one?
Possibly 3, maybe 2.
Ah, well done, Michael. So he said possibly 3. There's at least 2, right? 1, 2. But if we kind of zoom up a little bit,
They eventually
yeah, oh yeah, they do meet, don't they? So we should see 3 solutions. Let's see if we can't work with that. So let's see. Copy down example E. We've got 2x squared plus y equals 0. And then x cubed minus 3x minus y also equals 0. Addition or substitution both work pretty much about the same. I guess because of the convenience, one of those methods appeals to me more than the other. What's appealing to you? What looks good?
I would say addition off the bat, but I did want to ask if they both equal 0, are there cases where it would be economical to just have them equal each other?
You could do that, sure. Yeah, you could do that. Let's see. Would that exactly... let me say I think you could do that. I'm trying to run through the math if you set them equal to each other because they're equal to 0. You know, as I'm looking at that, let's see, 2x squared. That, you know, I'm not seeing that it works off the top of my head, but I'm not trying to put pen to paper at the moment. So, but I do know what will work, and that is if you add these two equations together. Meredith, what's going to happen if I add these two equations together?
X cubed plus 2x squared minus 3x equals 0.
Nice. What would you do to solve this? Is this going all the way back to our chapter 3 work? Polynomials? Oh yeah, kicking it old school. All right, but this one's not so bad, is it? Why? What's a little bit more user friendly about this one?
One thing you could do is you could move the one x out to get x squared plus 2x minus 3.
All right, so we'll factor out the x. Good. Can we factor what we have here any further? Elizabeth?
Yes.
X plus 3, x minus 1.
X plus 3, x minus 1. Wow. Hey, that wasn't so bad. Wait a minute. Can I give it some love? Yes? Love?
That was easy.
Yeah. Cool. Cool. So what are our solutions as far as x is concerned? Zero, -3, and 1, right? Now, how about if I had to figure out what the y values were? What would I do to find the y values?
Plug each of these back in.
Yeah, I'd plug it back into the first equation. Looks easiest, right? Because remember, you have y equals -2x squared. So if I set x equal to 0, so x equals 0 would give me y equals 0. So 0, 0 is a solution. If I plug in a -3, and you're careful, you'll get a -18. And if I plug in a 1, I get a -2. So, yeah, not so bad. And if we click back on our graph, we see we get exactly those points as solutions. So, 1, -2, 0, 0, and -3, -18. Perfect. Exactly 3 solutions there. Okay, looking good on that one. Let's jump up an example. We're going to skip example F, and we're going to go to example G here. So example G. A little bit of a different twist here on some of these things. We've got x squared y equals 9, which is a funky looking graph. And then x squared plus 4y plus 12 equals 0. You think we're going to be able to use the addition method to clean this up? Nora and Syed are shaking their heads no. Like, no, it's not going to work. So what can we do? There's always the addition method, right? If I was going to solve for something, I think solving for y from the first equation would be the easiest. What does y equal? 9 over x squared. So great, we're going to take that and plug that in for y. Okay. So this is going to give me x squared plus 4 times 9 over x squared plus 12 equals 0. And before your gag reflex kicks in, let's clean up the mess here of all these fractions. You've got x squared plus 36 over x squared plus 12 equals 0. Okay. Well, promise to clean up the fractions. Let me take care of that. What would you do to clean up the fractions in this one?
All over x squared.
Multiply by x squared, right? Because x squared is your lowest common denominator. We'll multiply everything by x squared. So x squared times this, times this, times this, times this. I'll be helpful. I'll do the right-hand side. Wait, we get a 0. On the left-hand side, what do we get here? X squared times x squared is x to the 4th. But are you adding or multiplying when you multiply these together to get x to the 4th? You're adding, yeah. When you multiply things with the same base, you add their exponents. The x squared here cancels out, so I'll have a plus 36 and then a 12x squared. This actually factors. You may look at that and go, oh, well, yeah, maybe it kind of factors. In fact, we dealt with that kind of factorization in the last section. It's x squared plus 6 times x squared plus 6. And that's nice. It's already nice and factored. So just kind of like this. You have something times something times something equals 0. One of those somethings has to be 0. So our choice is x squared plus 6 equals 0. What does x equal? there's a problem here.
You can't have it.
You're going to get an imaginary solution. We can only deal with real solutions. So these don't cross each other in a real way. What do you think I'm going to see when I look at the graph of this? What's that graph going to look like? Other than a mess, you know, what should I see when I look at the graph? What important feature? Yeah, a gap. Should I see these things cross each other? Should these graphs touch each other at all? No, they shouldn't. In fact, had we started out with the graph, we probably could have saved ourselves a lot of time. So let's see, let's skip down here to G, and bam. These graphs don't touch each other at all, so it's not a surprise that they didn't intersect. There's no solution. We are not going to use complex answers for our solutions to this, so there's no solution. No solution. The graphs don't cross. Now there's one last thing that I'm going to help you out with, and we'll do it with example H, and it's just kind of a review. Just a review of some of your calculator skills. So let's look back at example H. It says find all solutions to the system of equations. I'm going to take a little bit of extra time here and help you solve this on your graphing calculator. Now we're not going to get nice exact solutions, but that's okay. We can kind of figure out things based on our inexact solutions. So let me copy this down, example H. And let's see, we've got x squared plus y squared equals 23, and x squared minus y squared equals 5. So graph of a circle and a graph of a parabola. Now I can't directly plug these into my graphing calculator. It's just not going to like it. So what you would have to do is solve for y in both of these.
Also, another way to put it in, couldn't you also just move the 23 and the 5 to the other side as well?
Well, in this one I'm going to move the x squared to the other side, 23 minus x squared, and then take the square root, 23 minus x squared. Can anyone tell me what mistake I made in solving for y here?
Plus or minus.
Plus or minus. On top of that again. Well done. Over here, I'll move the 5 to the right-hand side, or 5 to the left-hand side and y to the right-hand side, and do the same kind of trick again. So now I've got each of these equations. It's just, plugging those into my calculator is just not a whole lot of fun. But I'm going to show you another little trick here in terms of plugging those in. I need to plug them in separately. I don't have a plus or minus that's going to work with my calculator. So hit the y equals key on your graphing calculator. And let me just clear out some of this stuff here. I've already got one of these equations in. So in y1, we'll put the square root of 23 minus x squared. And I know I've always kind of been a little shy on showing you some of these calculator tricks, but I'll make up for it here, right? So has everyone got ny1, the positive root? For the second equation, what we want is the opposite of the first one, right? We just want the negative of that. Now you could type in negative square root of 23 minus x squared and you'd be fine. Nothing wrong with that at all. But here's the little trick. Let's put in the negative, and then I want the negative of y1. And I'm going to show you where to find y1 in your calculator. So hit the vars key, and then it says y vars. So you hit the vars key, which is right here, go to the right, it says y vars, and you want to click the first one because we're working with functions, and there you go, there's y1. So the negative of y1, okay, that's kind of cool. Let's go down and put the next one in. So the next one was the square root of x squared minus 5. And this time I want to put in the opposite of what? I want to put in the opposite of y3. So let me clear out these down below so you can kind of follow along with my keystrokes again. You're going to hit the vars key, cursor to the once, cursor to the right once, y vars, press enter. This time I want to choose the third option down, the opposite of y3. So there you go. So a little bit of a trick, kind of nice. Where to graph this? Tough to say because you're not really overly familiar with these graphs. So a good kind of general shotgun approach would be just to hit zoom standard, which is zoom and then a 6. That sets your window to -10 to 10, and then wow. So we've got all these graphs. How many points of intersection does it look like in this one? 1, 2, 3, 4. So it looks like there's 4 points of intersection. Let's find at least one of them. So let me remind you how to find those. We're going to go to the calculate menu and find an intersection. We want to intersect between the black curve and the blue curve. So keep an eye on the color of these curves. If you hit second and then calc, so let me clear out these again so you can follow along my keystrokes. Second and calc, we want to find the intersection. So let's cursor over here. We're on the blue curve. And you just want to get close to, you don't have to get right on top of the intersection, and press enter. Now notice at the bottom you see that you're on the blue curve. When I press enter, it puts me on the red curve. That's not the one I want. So hit the down arrow key. And that puts me on the black curve, which is where I want to be. Press enter, and one more time, enter again. There's your intersection. So x is 3.714 and y is 3. We could probably figure out what x is exactly. Are we okay with this part right here? Were you able to get that? Let me see by hands. How many people were able to get that point? Well done. Well done. Way to go. So let's clear out of this for a second. This value of x is stored in our calculator. I'm thinking that that value of x is a square root. So there's x. Just type out x. Hit the square key. Let's see if we get lucky. Oh, how about that? Ooh, give it up. That was pretty cool. Nice. So you can check your answers. I'm still going to want to see some work, but there's nothing wrong with checking your answers there. Now, you're in total going to get 4 solutions. Be careful with that, but at least you have a way to work with this with your graphing calculators. All right. Comments or thoughts on that last one? Looking good there? Was that a couple good tricks? Yes? All right. Thank you. All right. I will post this on YouTube.